the road that the DRL engineers took to accomplish this insane 163 mile per hour speed record, multiple directions, and a single way speed record of 179 miles per hour. But first, let's take a look at DRL. DRL has really done an incredible job up to this point. They've gotten a lot of criticism from the hobby community for various things, but you have to also consider that there's nobody else doing things on the level that they're doing, and they're doing a pretty damn good job. Yeah, there's always places that they can improve, but look what they've accomplished. Look at the awareness that they've spread about engineering, about the sport, about the audience connecting with the sport. And when you look back to what they started building way back when, yeah, it looks pretty ridiculous, but you also have to understand what they're trying to do. Their concept of this kind of a sport is to make it kind of closer to what people are used to watching, like car racing, boat racing, motorcycle racing, plane racing. So they like viewing things from the outside. And so they got to put lights all over these things. And then they also got to carry a GoPro. And then they also got to have all the video systems working, which is no small feat. They're doing something magical in there, which they haven't even shared with us yet. So when you look at what they are flying now, it's night and day difference compared to what it was before, but it still doesn't perform the way we are used to our own hobby crafts performing. But again, you got to understand what they're doing here, and it's pretty amazing. That being said, lately they have shown their engineering prowess, and they have done that in a big way. When I first heard about this speed record, I thought it was completely unbelievable. And after going through this analysis and letting the numbers jumble around in my head for a couple days, I realized that it is kind of just on the edge of possible. And I mean, it's a Guinness Book World Record, so it's obviously legitimate. But when I compare it to my previous experiences and what I've seen, it's a pretty shocking difference. And that's what I'm going to go over in this kind of review of the craft. Fortunately, they have told us most of the parts and most of the story about how they put this thing together, and I would really wish that they made like an episode on the road to the world speed record of quads or something, because I know that they've done a lot of testing to get to this point. You can't just throw all the best stuff into something and expect it to get the fastest speed in the world. Like it's not that easy. Let's start with this picture that kind of just lays out all the parts that they're using and just discuss what's in this picture, because I'm not sure that these are actually all the parts that they used on the final craft that did the speed record. Probably somewhere along the way in their testing, they took this picture. And it's an interesting picture. What you don't see in this picture is very telling. They don't show some very crucial aspects of this craft. Something that's very crucial is the power distribution. Power distribution for this much power is not a small task. And they don't show how they did it here. I'm sure it was something substantial. It couldn't have just been, a couple of wires clumped together. This is a substantial amount of power. You have to consider, how to get the power evenly distributed across the system. And one thing that people probably don't realize as much is the little square that you see off in the left side, top left corner, that is actually a BEC. That component is probably one of the most crucial components of the whole craft. That is the first component that usually fails when we, typical people, try to run 5S, 6S on our 4S quads, because the BECs just can't handle the current switching to be able to knock the current down to the voltage that we need to power our systems. So they went with a much more robust BEC, I'm assuming that's the 5-volt BEC. And then next, you're going to look at the VTX that they're using. It looks like it's a Unify VTX. I'm not sure if it's the HV or if it's the 5-volt version. It might be the 5-volt version. I don't know. I wouldn't be surprised if the HV version can handle 10S no problem. And after that, you could look at the control system. They're using Crossfire. Crossfire is a great system. It's a very stable control link. So, it's a great choice. After that, you'll see the XT60 connector on what looks like 14 gauge or 16 gauge, probably 14 gauge wire. I'm not sure that's what they used, because I don't know if an XT60 is going to be enough to handle all these amps. Maybe it is because they're using 2 batteries. I don't know. Maybe because it's being distributed between multiple XT60 connectors. Not sure, but it will probably work for a short amount of time, a couple of seconds. And now let's get into the actual meat of the craft. The prop that they're using, or at least that appears in the video and most of the other pictures, is the APC 5x45 prop. Now, APC is a great company to choose props from for speedruns and a lot of other things because they make a great prop, but also the props are made of a glass nylon material that is really, really stiff. They have really aggressive pitches and they just perform really well. You can't really use a typical dull or other polycarbonate prop because under these kinds of RPMs and speeds, it's just going to explode. It's not going to handle it. So APC is a very popular choice. It's not the only choice. I think there are maybe one or two other props out there that can handle these kinds of RPMs, but it's a very good choice for this kind of a attempt. Next, let's look at the motor. The motor is the T-Motor F80, which I believe is a 2408 motor. I think this is the biggest motor in the mini quad class motors that's available today, and it's necessary to have this large of a motor. The version that they said that they're using is the 2500 kV version. Now, this motor does come in other kV versions. I'm not sure why they chose the 2500 kV. Again, I'd really love to know if they tested all the other various KVs and decided that this is the fastest one. But when you're running super high voltage, super high wattage, super high amps, the big stator of the motor just does a much better job at converting the power to actual thrust and actual speed. So, I mean, this is probably one of two choices that they could have made, and it's the better choice because it's from T-Motor. I think the other option that is in this kind of size class and is still a mini quad motor, which is geared at speed performance, not efficiency performance, like an aerial platform or aerial video platform or something, is the Thor, the DYS 2408 motor, which I'm not sure if it has the same build quality. I haven't actually held it in my hand, but I do know that T-Motors have good performance build quality. So, there's a motor choice for you. If you like to attempt this speed run, you got to look for a really, really big motor that can handle all that power. Next, let's look at the ESCs. These ESCs are the B-Rotor 80 amp ESCs. These are pretty new ESCs, I think. They're probably 4 months old. I think I remember them coming out 3 or 4 months old. And they're the biggest ESC option that I know of to date that can handle D-Shot 600 and all of the new stuff that all our little mini quad ESCs can handle, except that this thing is rated to 8S and 80 amps, which is a ridiculous number. Now, I'm not sure if they're using that cap because if you're using a cap for 10S, you're going to need a higher voltage cap than that because 10S is going to give you 42 volts. And if your cap is only 50 volts and your 10S battery is spiking past 50 volts, and then that just negates your cap. So they're probably using different capacitors. I'm not sure, but it would make sense for them to use a different capacitor on there, which they haven't shown here. One thing about ESCs to note is that, yeah, I know this ESC is only rated to 8S, but when you think about going up in voltage, going from 4S to 5S is a 25% jump in voltage. Going from 5S to 6S is a 20% jump in performance, and going from 6S to 10S is a 75% jump in voltage. Basically, what I'm trying to tell you is that as you go up in the S's, the amount of voltage that you're adding is a smaller and smaller and smaller number. And back in the day with the XM20 ESC that came out a long time ago, people started running 6S on that ESC pretty soon. That ESC was only rated to 4S and would still catch fire at 4S. But if you put the appropriate caps on it and ran it properly, it could do 6S, and it kind of did it all day. Matty Stunts ran that ESC a lot. It was impressive that it could do what it could do. So, I mean, ESCs are ESCs. They're really pushing the limits here, and there's probably many times when they just plugged the battery in and one of the ESCs caught fire. Something else very interesting about ESCs is that they actually have an easier time running flat out wide open throttle or at zero throttle than they do somewhere in the middle throttle range. So in the video, you see that the craft kind of crashed after it did the speed run. I'm guessing that may have been as it was coming down in the throttle range, or the motor braking may have caused that because it has to do more active stuff to cause the motor braking when you reduce the throttle. But maybe they just turned off motor braking. I don't know, but this is currently, as far as I know, the only ESC option that can handle anything like that. Now let's look at the flight controller. I can't exactly identify what the flight controller is, but I'm pretty sure it's an older model one because the MCU on it looks small, and I'm pretty sure it's an F3 F3 flight controller, M3 chip on there. So it's probably older. I don't know if this is what they actually used. Might have just been something they had lying around from a previous build that they threw in here for the picture. But I do remember that back in the day when I was running F3s, maybe even F1s, the crafts that I was building, I was putting 6S on them, and they had no problems running at all. I was hard mounting everything back then too, and it just worked. I'm not sure if it was just the gyros that were less sensitive back then, or the code that just didn't care as much when you're running high voltages. But the code today is very, very sensitive. It's very good at performing in a wide range of situations, but it's very sensitive. Anybody that's tried to run 6-inch props with 6S knows that it's a little, you got to do some trickery to get it to work properly. So again, this is going to take some testing if you're planning on trying to run 10S. Maybe they used an older flight controller with a maybe less sensitive gyro so that it could better manage the vibrations that will most likely happen when you're running at RPMs that are just ridiculous. So maybe that's a specific choice they made, or maybe they just had it lying around. I'm not sure. Next, let's look at the frame. They've chosen to go with a very minimalistic frame and nothing special in terms of aerodynamics. It's just an X frame, which I personally would completely agree with. I know there's a lot of these vertical arm frames coming out and various other things that people are trying to do to improve aerodynamics. We really don't know if any of that stuff improves aerodynamics, and just the skinny arm frame that's minimalistic is probably not going to make that huge of a difference. Of course, this is an area that may make a pretty big difference. I don't know. We don't know. Nobody's really done wind tunnel testing that I know that can tell me, or anybody else, that if it's going to make a big difference. I've spoken to an aerodynamics engineer at Caltech, and they think that it will make a big difference, but I'm not sure. Maybe this is an area where people can improve upon. Maybe based on your frame selection, you can actually get a little bit more speed out of this craft. Who knows? Next, you look at the batteries. The battery that they say that they have gone with is the R-Line 1300 5S pack, and they're running 2 of them in series to give them 10S. Now, this is a very specific battery, and I'm sure they just chose the R-Line because it's the top cell in the industry. That, and I think the Thunder Power Adrenaline cells are some of the top batteries in the industry, but they chose to use a 1300 pack in series to give them 10S. That's a very specific battery combination. I'm not sure how much, we don't know, but I'm not sure how much testing they may have done to come to the conclusion that that is probably the optimal battery selection. But let's just break down the voltages and the wattage of this battery to see what kind of power it can deliver. So I know all these C ratings are bogus, but if you consider these batteries to be able to deliver 100 C, just put out a standard number, 100 C, for a couple of moments, a second or two, which is really all you need for these kind of speed runs. Let's look at how much wattage this battery is going to put out. So 2 1300 cells in series to give you 10S at 100 C is going to be 4,800 watts at normal voltage. That's 3.7 volts normal voltage. On a full charge, you're getting 5,460 watts. That's pretty nutty. Let's go a step further, and I would think maybe they decided to charge the batteries to high voltage, which is 4.3 volts, and that is 5,655 watts. That's a lot of wattage. Additionally, there's one other aspect of batteries that is not really discussed in the multi-rotor community, but the RC car guys and the boat guys know about this, and they've been doing this for a long time now. I think people are starting to do it in the multi-rotor community, but in general, if you heat up a battery, you tend to be able to suck more power out of it throughout its kind of function. And anybody that's flown in a really cold environment has noticed that their quad just kind of has stunted performance. After about a minute of flight where the battery heats up, you feel like you can move a little bit better and it's really performing better. So I don't know if they did that, but it would be interesting to note if the craft was going faster in the initial run when we were doing the speed runs, or if it took 1 or 2 times and then it actually got faster. This is the part that to me gets really interesting now. I'd like to draw your attention to Horus Drones. Sharif of Horus Drones has been working with speed for a long time now. He's been doing it for well over a year, and he designs all these great frames and has now started making motors and doing other things as well. And he's been running gear that is kind of more stable. I don't know if you can really sustain a craft on 10S for multiple battery cycles and expect it to last. So Sharif is just running 6S and trying to get enough amps out of the 6S in order to get the speed that he wants. But 140 miles per hour is very different than 180 miles per hour. That's a lot of speed. As you go up in speed at these speeds, as you go up each mile per hour at these speeds, the resistance of air is exponentially higher. It's such a drastic amount higher that if you look at a car like the Bugatti Veyron, that thing needs an extra like 500 horsepower to make it the last 20 or 30 miles per hour at the top speed. So drag is not something to be taken lightly. Let's just look at the batteries that these two quads are using. The Esc S 1300 milliamp battery will give you about 5400 watts, and the Ec S 1500 milliamp battery that the Horus drone is using will give you about 3700 watts. You can't exactly extrapolate between the two quads, but if you think of the idea that it takes about 3800 watts to get to the first 140 miles per hour, and then it takes another roughly 1700 watts to get the next 40 miles per hour. So when you do the calculations, this is about 45% more power that's used to go 28% faster. When you average these numbers mile per mile, each mile per hour faster after 140 miles per hour takes about 55% more watts than less than 140 miles per hour. So exactly those numbers are, it takes about 42 watts per mile after 140 miles per hour and 27 watts per mile before 140 miles per hour. While 55% more power is kind of a large number, it's not yet astronomical to me based on my experience and my notions and just the hunch I get from looking at these numbers. So I don't think it's absolutely insane for us to maybe even see a faster top speed. And this is the calculation I did that really clicked it in my head and got me impressed, more impressed with what the future has to hold than with what they already did. If you visit the Horus drone site, he's actually laid out how to achieve the speed that he's achieved, and you can make your own modifications on it and maybe get a faster speed as well. I thought it was a very, very interesting comparison when I compared these two crafts to see how much faster the DRL quad was able to move than the Horus quad. I mean, they shattered the speed record. This is not just a little bit of more speed. That is a ridiculously high amount of speed. That's a lot more speed. I'm not really sure why they did this. Maybe they just did it to show that they can, or they did it to gain publicity. I'm not sure, but I also appreciate that they really showed us, or they at least told us, mostly the parts that they used and how they kind of did it, or we can extrapolate at least how they did it. So now we've got two groups that have shared how they've gotten the speed that they've gotten. And those are some really important data points for us to use going forward. And now that this has happened, I know that there's at least 5 other people building this quad just to try to achieve the same speed. In fact, I know somebody here on the West Coast which is building pretty much the same quad to see if he can achieve this speed. He's been trying to hit 150 miles per hour for a while now, and he's built a lot of them to try to get that speed. And this is not a dumb guy. He definitely knows what he's doing. But now that this has happened, and if you really dig into the way they did it, maybe there's areas for improvement. I mean, DRL didn't custom develop all of the components that they used for this high-speed record. Maybe they actually didn't put that much effort into it. Maybe their engineers are just really good at selecting components and they really know everything out there, and they put together a craft, 1 or 2 of them that could probably do it, and then just went out and started testing how much voltage it could take. We don't know. But now that we've actually accomplished this speed, now that they have shown that you can go really, really, really fast, I wouldn't be surprised if sometime this year somebody manages to hit 200 miles per hour, which is like a mind-blowing speed for these things. And here's something else really, really interesting to note. Our FPV feed is roughly about 50 milliseconds delayed if you're using an HS1177, the Sony 600 CCD sensor, and all the latency in the system, you're getting about a 50 millisecond latency overall. At 180 miles per hour, 50 milliseconds of latency is 13.2 feet. That's a pretty ridiculous number to think about. At 200 miles per hour, a 50 millisecond delay would be a little over 14 feet. That's a scary thought. So if you're attempting these speed runs, make sure you're at least maybe 50 feet off the ground, just to be safe. Anyways, this is quite the fun engineering challenge, and I can't wait to see what comes next. Don't forget to floss.